creating your first 3D printable project within FreeCAD. If you enjoy this video and you find it useful and want to see more like it, make sure that you give it a thumbs up. I'm Jonathan and welcome to Maker Tales, where I'm sharing my maker journey to help you go further in yours. This video is sponsored by Thangs. As I've just mentioned, in this video we're going to be creating our first 3D printable project. Now we're very much going to focus on direct modeling so that in the future videos we can focus on parametric modeling. With that said, let's jump straight into it. And we've reached a point that we're really starting to become familiar with the Sketcher workbench. We know how to create a whole bunch of lines, how to do an incredible amount of operations with those lines, and how to constrain those lines both geometrically and dimensionally. And if you do not know how to do that, I really suggest that you take a look at the earlier videos before you dive into this one, because this video, we're going to pull together everything we've just learned and dive into some pure direct modeling. As a quick recap, direct modeling means we will be creating this model right here by putting in every single dimension manually. And then once we've done that, we're going to learn something called direct reference modeling. It's very close to direct modeling. It's sort of the gray area between direct modeling and parametric modeling. And what this basically means is we're going to create the entire model once again using references. And this affords us this flexibility to be able to sort of change the entire model very quickly. Now don't get confused, this is not parametric modeling. There is not an equation or a spreadsheet to be seen. Yes, it has a lot of parametric elements to it, and if you really wanted to be pedantic, you could say this is parametric, but it isn't because of the references. Now this is all built with references from sketch to sketch or from object to sketch. And just as an example, if we go back to the pure direct modeling, if we were to do a change like that, well, it really wouldn't work. We would need to change a lot more. Now I'm going to show you both of these within this video because I want you to develop a deeper understanding of FreeCAD, all the workflows that are available to us, and just sort of see that it can be as flexible as you want it to be. With that said, let's go and create a new file and create your first 3D printable project. To start off with, we need to know exactly what it is we're going to be modeling. Well, down in the description there is this free technical drawing that you can go and download to follow along with. With that said, let's close this up. Let's create ourselves a new file and straight away save it with Control S. And I'm going to save this file as pure direct modeling. I'll hit save. And as always, let's create our part and then our body. Now I'm going to be very meticulous about my naming because I want to keep on top of it from right at the get-go. So I'm going to rename this as the box, and this body, I'm going to rename it as box_body. As you can imagine, we'll start this all off by creating a sketch on the XY plane. So from the top down, we'll click OK. And to begin with, I'll go nice and slowly. I'll mention everything that I'm doing, and then slowly but surely, I'll go faster and faster. So we'll press R, create ourselves a rectangle here, and the entirety of my whole design is going to be centrifugally locked. So the main root origin of all my design is going to be center-based, which means that I'm going to select these two here, this origin point in the middle, press S and create a symmetry lock. So straight away, now FreeCAD knows where this is in the 3D environment, and it has the bonus that this locks down quite a few degrees of freedom. Now I'm going to select these two edges here, make them equal because I'm creating a square here, and then I'm going to select this edge here and put a final dimension with Shift V, and we'll put in 70 as the technical drawing tells us. We'll click OK, and there it is, a fully defined sketch, nice and simple. We'll click close, and I'm going to straight away rename this sketch with box_base. Now I don't need to say that it's the sketch because the symbol is right there and it's the root sort of thing of the object that I'm creating. And if you're wondering why I'm doing underscores and all the rest, this has a lot to do with my own personal naming convention as well as equations when we get into parametric modeling. So I just want to show you the way that I do it. So I'm going to select it here. We're going to pad this out. We can see that this should be 70 from the technical drawing. We'll click OK and rename that pad. So keeping the pad this time though, but I'm going to go with box_base and underscore. So this way I know that it's the box base sketch and that the pad is deriving from that sketch. Okay, now let's go and create this pocket. Now there are other ways of sort of hollowing this out, but I very much want to stay with this sketched based design to start with, and then we're going to go into some other operations in future videos. So let's create a sketch. And it's the exact same workflow here. We're going to create a rectangle. We will select those 3 points. So the 2 diagonal points and the center one. Press S for symmetry. These 2 here, we'll press E for equal. And now we've got to dimension this one here. So Shift V. And the way that this one's working, it's basically 70 minus 1.5 minus 1.5. Now, you could do all this in here, or you could just put in the number. It's up to you. But the 1.5 is the thickness of the wall. We'll click OK, and lo and behold, we have 67. And this is now fully constrained. So we'll click OK. We'll rename this sketch right here. I'm going to call this box underscore hole. We will pocket this. And I'm going to just type in 70 minus 3 because the thickness of the base is 3 millimeters. Click OK. And there we have it. Let's just rename that pocket now. So I'm going to call this box hole pocket. And we have our first part created. So I'm going to close this down here. I'm going to hide the box because everything is center based. I'm going to create a new part, which will be our lid. We'll create a new body and we'll straight away rename this. So this first one is lid and the next one is lid body. Now be sure that you hide your box. If not, it's going to get a little bit in the way while we're creating our lid because everything is made in the same exact place. So let's create this lid. As you can imagine, we'll create a sketch. On the XY, we'll click OK. Then we'll do exactly the same thing here. So we'll create that rectangle, create these 3 points to be symmetrical. There it is. Those 2 to be equal. This one, we'll dimension it with 70 and click OK. I'll just move this out to the side to make it look pretty and click close. Then I'll rename this sketch lid base, and now we will pad this out by 3 millimeters as the technical drawing tells us. I'll rename that pad as lid base pad, and now we will go and create the lip. Create a sketch, create the rectangle, select the points, make it symmetrical, make these equal, add the dimension. Now the dimension might be a little bit weird for you here, but basically it's because there's a bit of an offset. So you can just look at the technical drawing. It says 66.2, but I just want to explain what's going on here. This is 70 with a minus 1.5 and a minus 1.5 and then a minus 0.4 on each side because that is our tolerance of 3D printing. And that's how we get this 66.2. Now we have a fully constrained sketch. We'll click close. We will rename that sketch as lid lip. Then I will pad this out by 3 millimeters. Rename the pad as lid lip pad. And now let's add that hole. So we'll select this one, create a sketch. We're going to go from the center, create ourselves a nice little circle. Straight away, just give it a dimension here of a diameter of 20 millimeters. And as because this is all center based, it's already fully constrained there, excuse me. And then I'll rename this sketch as lid hole. I will then pocket this down. We're going to go all the way up to a face on the bottom here. Click OK. Come back up to this view here. And I'll rename that pocket as lid hole pocket. And lastly, we need to do something called chamfering. Now, don't worry, it's not that crazy. It's this operation right here. And all I'm going to do is select this face and hold down Control and select this bottom edge. Now, the reason why I'm doing this is that is all the edges that are chamfered by that 1 millimeter. So I'll click this chamfer here and we have this 1 millimeter dimension right there. And then I'll click OK. I'll just quickly rename this as lid chamfer. And with that now renamed, we have the lid and the body done. So let's make these both visible and oh dear, they're on top of each other. Don't worry, this is how CAD design should be done. On the same part, you do all the parts and then you sort of do an assembly later. Because this is pure direct modeling, we can do this though. We can just right click here and go transform, which gives us this nice movable gizmo here. So we can just move this out, click OK, And there we have our first direct modeling, pure direct modeling done. Thangs is a 3D model community for designers, engineers, and 3D enthusiasts. And behind it all, it's being powered by some insanely unique machine learning tech that pretty much looks at your 3D models. Not only does Thangs have millions of free models for you to download, but every model you upload to Thangs is examined by their tech to help you search and share them faster. Plus, you can even preview the models in augmented reality. So be sure to check Thangs out through the link in the description. Now let's jump straight into some direct reference modeling. I'm going to create a new file, straight away save this, and you guessed it, I'm going to go for direct reference modeling here and hit save. Then I'm going to create a new part, a new body, and keep on top of my naming convention, and straight away rename this with box and box body. With those now renamed, let's start this all off with a sketch on the XY once again and click OK. And this is pretty much the same as last time. We're going to create ourselves this rectangle, make everything center symmetried once again. So we'll go these three, press S, these two, press E. Then we're going to add our dimension to this line with Shift V, and we'll go for 70. Click OK, pretty much everything exactly the same so far. Click close, and we'll rename this. Now with box base, let's straight away pad this out with 70 millimeters once again, and we'll rename our pad, box base pad. We'll select this face, create the sketch, and here's where things are going to start to get a little bit different. Still, this is the same. We're going to create our rectangle. Once again, we will make this centered, and then we will make these two equal. But now I want a reference because I always want to have an offset here of 1.5 millimeters. I'm going to do a reference of external geometry. Remember, this means that this will not come up inside of the part design. This is just for us within our sketch. Now I'm going to go and create a construction line. I'm going to make this coincident with my top right corner, make this horizontal outwards. Then I'll select both of these and make these vertically constrained. And then I'll select this lovely little construction line and go Shift H and set this as a 1.5 millimeter offset. Now you can see the power of what we've just created here. Now we'll click close on this and we'll quickly rename that sketch with box hole. We'll pocket this now. Of course, we don't have anything to reference here, so I'm just going to go 70 minus 3 once again. We'll click OK on that and rename this pocket as box hole pocket, and we have our box created. Now it's time to work with our lid. Once again, we're going to create another part, another body, and quickly rename these. So now we have our lid part ready to go, but I want to be able to see some of the things of the box because, well, I'm going to be referencing from it. I don't need to see the actual box itself. What I need to see is the sketches. So I'm going to go into these operations and we'll see and make them visible right here, the box hole and the box space. I want them to be here within my 3D space so that I can work with them within the lid body itself. Now within the lid body, I'm going to create a new sketch. Once again on the XY, I'm going to click OK. Now we already have exactly what we're wanting here. So what I'm going to do is we're going to create a direct defining geometry reference of all this outer edge. Now with this done, we can click close and that's set. Now take a look at what's just been created here. So we have a sketch that we have to obviously rename. We will rename this as lid base. And because we did such good renaming, you can see on this here where it says import box base, well, that pretty much tells us exactly what's going on. The sketch box base is being imported by this thing here. In case you're wondering what exactly this thing here is, it's right here. This is called a shape binder. It's a little bit weird. It's sort of a way of creating a magical connection between different parts. So that's going to always be there. Now that we have this lid base, let's go and pad it out. Once again, we'll pad this out by 3 millimeters. Click OK, and let's rename that pad. With lid base pad renamed, you can see that this import stays out there because it's always going to be imported into this object. So other sketches can go ahead and reference from it. So we have this done here. Let's select the top face once again, create our sketch, and we already have sort of the outline of where we want to have our offset for our lid. Now, I don't need all of it. Again, I just need one little external geometry reference of that lovely little point right there. Now with that done, we sort of know exactly what we're going to be doing. We're going to create another rectangle. We're going to do this whole center locking once again. We will make these two equal. We will create that construction line. We're then going to select these 2 points and make them vertically constrained to one another. And then I'll select this. I'll do a horizontal dimension, and I just want an offset of 0.4 millimeters. This is the 3D printing offset of our lip. We'll click OK, and there we have it. We'll click close, and let's start renaming this sketch as lid lip. Then we're going to go and pad this lip out once again by 3 millimeters. We no longer need the other lines up in here, so let's just go and hide those out. We'll bring this pocket back, but now we'll hide the entire box. So we can just see our lid right there. Let's rename that pattern we just created. And now there's not much left. Let's select this top face, create that sketch, make sure that we're doing normal lines, not construction lines. We'll create our hole that we're going to be using once again. Once again, we need to diameter this hole by 20. Click OK. Then we'll click close. Let's rename that sketch. Lid hole renamed. Let's pocket this hole down. We're going through over to the face. Clicking OK. We will rename that pocket as lid hole pocket. And now lastly, we just need to do those chamfers. We'll select this face, select that edge, select the chamfer, 1 millimeter, click OK, and we'll rename that chamfer. And that there is our lid now created. So we're pretty much done. Let's turn on our box once again, and we can see that we have this problem of overlapping. Now, because this is so closely referenced to one another, we cannot move this through a transform. And let me just show you why. If we were to select this and go transform and then move this, click OK, well, we've just broken things. Things no longer really know what's going on. In fact, if we go over here, oh dear, that is definitely not what it's supposed to look like. What is going on there? This is because we have so many references going on. So let's just undo that movement. We don't want that. As you can see, we have all these check marks. Let's just recalculate them, tell it everything is fine. What we need to do is sort of create a weird copy of this lid to tell it, hey, look, all is fine. We just need to move you from where you are right this minute somewhere else. We don't need to actually move you, just your copy. We want to move your copy. And the way we do this is by creating a copy called a link. I'm going to create this by clicking that. I'm going to hide our lid. And then we have this link lid. With this link lid, we can right click, hit transform, and move that out. And we will have 0 problems within our model because everything is sort of linked and we're not moving the references themselves. Now don't get confused, this is not assembly. That can be a completely different video. This is just a very simple way of moving things around so that you can go ahead and get this ready for 3D printing. With that said, let's do exactly that. But just before we do that, I've decided that I want this box to be 75 millimeters. So to do this, I'm going to go into box, into my box body, into my box base pad, and into the box base itself. Then here, when we have sketch and constraints, I can change it right here, or I can double click into the sketch itself. I'm going to just change it here, click 75, click enter, and lo and behold, everything's changed. Okay, great. Now let's go and export this out as an STL to print. Well, to do this, you can go ahead and just sort of select both of these, go over to File, Export, and then select STL. But you're going to have mixed results there, especially when you start to get into more complicated designs. It's not going to have the full definition of what exactly you're wanting. So let me show you the full workflow here. What we're wanting to do is go to the Mesh Design workbench. So within here, we can select one of these and we can convert this from an object into a shape. A shape is a mesh. Set your surface deviation to as low as possible. So I'm going to set this to 0.001, which is 1 nanometer. And then here, the angle of deviation, the lowest is 1. We're going to click OK, and here is our mesh ready to export. But I don't want to export this individually. I want to export this as a whole mesh, all of this together. I don't want two different STLs. Well, to do that, we need to do one extra little step. We're going to go to the part design workbench. We're going to click on our box, and we're going to make a link of the box as well. So now we have a link box and a link lid. With both of these selected, I'm going to union them together so they sort of represent just one shape. Now that we have this fusion, so to speak, we can go over back to our mesh. With this fusion object, we can change this entire thing into a mesh. And now we can see that we have one mesh here ready to export out. Now to export out from the mesh design workbench, well, we're going to click the export button right here. So we'll click export mesh. Instead of calling this fusion mesh, I'm going to call this simple little box. Then we'll hit save, and let's take a look at this within our slicer. And here we are within Prusa Slicer. It's turned out perfectly, and because we use such low numbers when we were doing the tessellation to create this shape, you can see there's no sharp jagged edges around this round corner, which is exactly what we want. A high degree of precision coming from our models, especially when we're working with FreeCAD. Let's quickly slice this up, make sure that it's all looking good. It is indeed. I'll pull this down, see that there's no artifacts coming up. That's perfect. There you have your first 3D printable project coming from FreeCAD, and you truly understand how all of it was created, what direct modeling is, and what direct reference modeling is. Well done for getting through that direct modeling video. I really do hope that you're starting to feel a little bit more comfortable with FreeCAD and seeing all the puzzle pieces sort of start to join together. As you can see, there are two very different workflows, both very direct in nature, one doing direct references and one applying just direct inputs from you. Personally, I use direct reference modeling about 80% of the time. A huge thank you to my patrons. You guys are absolutely awesome, and it's the reason why I'm able to make these videos. And if you're enjoying what you're seeing here, you think I'm worthy of your support, I would love to see you there too. Don't forget that we have a Discord, and that's linked down in the description. Thank you for watching, keep making, and let the quest continue.